morning. So RubyConf. I'm excited. How are you doing today? My name is Minqi Pan. Uh, I came from China, Beijing, and I'm a hacker of Ruby and C++. I'm also a Node.js collaborator, so I do a lot of open source development. And this is my GitHub page, uh, and those are the links. Oh, I can take off this or not. And today we'll be talking about how to compile your Ruby application into a single executable. So where does the story come from? The other day I was installing the GitLab CI runner on the Windows machine because our project is in C#, and I thought, geez, GitLab was written in Ruby. It seems very hard to install Ruby on Windows. Probably I need to set up the Ruby environment and do some gem installs and stuff. But it turned out that's not the case. Um, they made a single executable for me to download. It's 46 megabyte. After I download that executable, I just mm, executed and installed a service on my CI machine, and voila, it works. So why is that? Because they're not writing the CI runner in Ruby, they're writing it in Go. So Go has this nice feature that can build your program into a single product that you're free to distribute. It feels so nice. So in order to solve this distribution problem, people we just need to drop Ruby and use Go. Thanks all for coming. But seriously though, um, some company does that indeed. Like Heroku, I remember, time ago when I installed Heroku CLI tools on my machine, on my Windows machine, there was an installer based on Ruby installer that basically installed the Ruby along with the Heroku's project code into my machine. But they changed that. The last time I tried Heroku CLI is no longer in Ruby. I guess it's also in Go or Node.js or something like that. So I'm kind of jealous about this situation about the Go language. Um, I love Ruby. I've been writing Ruby for years. I think we all do love Ruby, right? It's so sweet. We love the net language. So about this jealousy, I'm trying to bring that feature into the Ruby world. So what problem are we trying to solve here? Before we before the Ruby packer, um, how we distribute our program. Well, something somewhat like this. We have to first, assume that the user does not have Ruby installed on their machine. We have to first let them install the Ruby environment, and then probably install the REM, and then install Ruby, and those all take a long period of time to complete. I recorded those video in China, and they even got worse connection than the US, and that single step takes a long time. It's definitely not friendly to the end user. And also, finally, after you got the Ruby environment set up on the user's machine, you need to let them do some gem install stuff, and there are a lot of dependencies to download. I think overall, that's not a good experience. And if you consider Windows, that's a disaster. You have to, yeah. So the problem is the installation is slow, tons of files to download, and if in China the Great Wall is somewhat helps, it even makes the thing worse. And sometimes people forgot to use sudo, and it's error prone, especially with native modules. And you have to care about the Ruby runtime version. Say if you use the lonely operator that was introduced in Ruby 2.3, and the machine was installed with Ruby 2.1, then your program won't run. So, and also updating. After you distribute your program, you want to keep it up to date. So how we do that? Um, we have to do the same gem install thing again, and the user does not even know that you have a new version, right? And on Windows, you have to do the installer again. So no version checks, It's also cumbersome to update, as cumbersome as to install, I guess. So after I tried this packing your project into a single executable idea, it turned out to be much better. Look, you can compile your Ruby project into a single file. This is one project that I compiled. It weighs 40 megabytes. Um, and you can just execute it, dot slash your program, and it runs. And also, on Windows, the user no longer have to install those installers anymore. You drop a exe to them, 33 megabyte, and well, they cannot double click it because it's usually it's a command line interface. So you just bring up your CMD and it runs. And this is the best part. Updating has been made so much easier once you pack it into a single executable. Um, it feels so nice that I want to show it to you in the demo. So this is the program that I packed, and when it runs, it will check for a new version of it. And if it finds a new version, it will download the new version and replace itself. Well, the download step happens on a temporary directory. It downloads the file to some temporary location and move that file to this single place to replace itself. The network connection is a little bit slow, so we're probably not going. But um, I've prepared for this, so I have a recording. It was fast when I recorded that. Yeah, it inflated the thing and replaced. Look, and it resumed the execution, and you now got 0.4. And it happens on Windows as well. So you can sort of just put a self-check for versions on when your program begins, and uh, the updating process is so easy because it's just one file. You just need to replace yourself. That's the idea. Um, and the tool that I made uh, will help you produce executables like this. Um, you can get the source code of the tool from this address. It's on my um, GitHub page. It's called RubyPacker. And I even made a homepage for it. It's used to prove the idea that this thing works, because this tool itself was written in Ruby, and this tool is used to compile Ruby projects, so it must be able to compile itself. So this is an example of the thing that it compiles. It actually can generate those files on 3 platforms: Windows, Mac, and Linux. You can just download, and it works out of the box. So, uh, how to use this tool? Well, there are several scenarios. The first scenario is I have this tool installed at this location. If I don't give it any arguments, it will just try to produce a single Ruby executable that is blank. It's just the single Ruby executable, interpreter executable, how it looks after it's finished. I have some examples here. This is the final product, and if you execute it, it's just a Ruby executable, so you can like print 1 plus 1 and this 2. Um, so I wish Ruby was distributed in this way. Actually, it's not. Currently, Ruby was distributed in source code form, um, and there's no uh, uh, almost no binary distribution. And there is some for the the Ruby installer, but that distribution contains so many files. The standard library is so huge. What if we can distribute Ruby in just one single executable? That would be so better, I think. And um, but you must have said that Ruby contains so many things. It's just not one single executable. There that contains IRB. Um, well, IRB is inside this. We'll tell you how it works later. But let's see another scenario where you can use this tool. Um, is the ordinary scenario where you want to compile your own project. Say if you have a Ruby project, uh, like the one that I got here, um, you just give the entrance uh, of that project to this tool, like being Ruby C, and it will begin compiling. And after that, you will get an executable for your Ruby project. And that's usually the main scenario that is supposed to be used. And since this Ruby conference is totally on Rails, we cannot forget about Rails. So if you have a Rails project, you can use this tool with the entrance set to bin/Rails, and they will produce a um, single executable for your Ruby, for your Rails project. I have already compiled one here, so we can show it. Like this executable, you can see it's 38 megabytes, and I can run it. Uh, and they will say you have to add another command. Let's run it as server. Rails always starts a little bit slow. Then you go to localhost 3000. Yeah, you're on Rails. And the fourth scenario is you can actually pass it a gem to let it compile the gem. And also there are parameters for you to specify auto update URL to check for new versions, so that the auto updating part is built in. And that's because I made this tool on top of another library called lib auto update. And that library basically abstracts away the difference between Windows and Linux, and use the socket functions to communicate with the server to check for new versions. Um, so what happens under the hood? How did we make this work? Um, the basic idea is we put your project into something like a mounted disk in your memory along with the Ruby interpreter. And we mounted it at a special location called underscore underscore enclose IO memfs. Uh, you probably already seen that in the backtrace. So that is like a virtual file system in memory. And if you, um, we can do a demo here. Uh, I'll put a, we can use the other one, the Ruby interpreter, the blank Ruby interpreter that we compiled, and we can give it a entrance, and that entrance you can even reference a file inside the virtual file system, and that's the reason why we can bring up the IRB. And if you look at the load path, that is all in the virtual file system that is actually in memory, part of the executable. Um, so that when you require something, it actually will search inside this virtual memory to give you that. And you can do all kinds of file system operations on it, and it all just works. Like if I wonder what is on the root path of this virtual memory, um, there being include lib and share. So Ruby standard library is actually embedded inside this single executable. It's inside lib Ruby. Uh, well, you used to have this huge library installed on your system, but now it's embedded inside this executable. So all the global level gems are there. This is very similar to what you would install on your machine. Uh, and you can even read file out of it, like file.read, give it a virtual path, IRB. Look, that's the IRB that we just evoked. So that's the idea. And also, the normal files are, uh, you can also read normal files. And they're like, if I want to see what is on my what is on the root path of the user's disk. Oops. And those are reading from the outside. So it's a combination of a in-memory file system and the real file system. The key is if it starts with this string, it goes into itself. Otherwise, it goes to the outside. That's the idea. And all kinds of file operations are supported on this virtual file system. Like I can read this file and I can get its.
It's 11 hours.
I can get its metadata. At the time that I compile this, you see all the those information are stored when I compile this project. So that's the idea. Whatever starts with this path goes to your memory. The others still goes to your disk. So where is your project? We put your project into a special location under this virtual directory called the local. If you use this tool to compile your project, you would find your project appear at the location. So to wrap it up, you then hard code an entrance. Because you used to run your project use the Ruby via the Ruby interpreter and put your entrance at the argv bracket 1 location. But now, since we have compiled this into one single executable, we just preset the argv1 to your location so that the user, when the user fetches your final executable, it just runs from this location and it just works. So how do we do this? There are so many file APIs. We cannot hack them one by one to add this special functionality, right? It's just not maintainable. Ruby is subject to change. Their 2.5 is coming up. So we did not change on the Ruby level. Yes, we hacked some code on the Ruby level, but in a limited way. Like Ruby IO.c is the source code for a lot of IO operations. We didn't change much. We just included the extra header to intercept some of the system calls. And most of the logic is actually inside this small library. It's called the libsquash. What is libsquash? That is actually the core part of it. Um, well, want to take this opportunity to thank a few people. It's not this library is not solely made by me. Dave Walilewski made a library called Squash Fuse. It is a Fuse. It is a file system implementation. The Squash file system implementation on Fuse, and I take lots of code from him and make it into a library. Uh, and also, this is my good buddy. He's called Shenyuan Liu, and he helped me write this library as well. So this library basically implements Squash FS. How many of you have heard of this file system? Oh, thank you. Very few people. Squash FS is a compressed read-only file system that was used by live CD versions of many Linux distributions. Like I used to play with the Ubuntu live CD, and the live CD was actually a Squash FS that can be mounted by the kernel when you run it, and also used by some router companies as their firmware. So when we are trying to invent this tool to compile your project, we are looking for a data structure to hold it, and I was looking for different options, and I think this Squash FS data structure fits our needs. And it has been there for a while, it's stable, so we use that. And we try the effectiveness of it. If your project weighs over 100 megabyte, after making it into a Squash FS file, it being compressed into just like 16 megabyte. And there are tools for it. It's called MK Squash FS. It compiles your project. Meanwhile, made the final data structure being able to arbitrarily access, randomly access. So it's a good data structure. the compressing part is important. You don't want the user to have a huge file when you distribute it to them. You cannot let them download something like a multi-hundred megabyte that is unfriendly as well. It takes a long time to download and update. So we choose one with compressing in it. And um, that is actually part of the Linux kernel since 2009. So we cannot just use that because it's GPL licensed and the code is part of the kernel. You cannot use it on the application level because like the malloc are just kmalloc. They're part of the they're not at the user level. It's the kernel level. So we cannot use the original implementation. So that's when I found the squash fuse. It's a fuse implementation, so it's on the user space, um, and it's MIT licensed. So I took his code and made another library called lib squash um, that removes the fuse part out of it, um, because we don't want to make any assumptions about users' environment. We do not want to assume that they have fuse. We don't need that. So it does not depend on Fuse. It's just a library implementing the Squash FS access part of it, and it's MIT licensed because the fork project is also MIT licensed. So that's actually an important point. I'm not going to expand on that because time is running up. And also it compiles on 3 platforms: Windows, Linux, Mac, so that if you use this, your application is super distributable. And this is the important part. I designed this library to make it mirror the system calls, to mirror a lot of system calls. So it's just it can just come as an in-place replacement for a lot of system calls, the file system ones. And this is another important design. A lot of system calls do not have path in it. I have to, distinguish the path that begins with enclosed underscore that special string and path that do not. Some system calls like open, read, write, they actually work on file, file descriptors. They're just integers. How do I know that a file descriptor was opened on a virtual file or a real file? So I have to come up with something like a virtual file descriptor. Like if you do open call at the first time, it has a path in it, and I will distinguish if this is a real path or a virtual path. If it is virtual path, I issue you a virtual file descriptor, and that was actually generated by this system call. I duped the 0 file descriptor to make it look like a file descriptor and let it coexist with other FDs issued by the system. But I have it in my record. I have a global data structure called global FD table so that I remember what FD are issued by me and what are not. So after you get that FD and made some calls after that, like read, then I will check if this is my FD or the system's FD. If it is my FD, then I will read the data for you from the Squash FS. Otherwise, it will send to the operating system. So this is how the header, the magic header, works. I just intercepted a lot of system calls and redirected to that one. And uh, we we spend a lot of time hacking Windows as well. Look how ugly are they. We intercepted those calls as well. So it works on Windows as well. So what about native extensions? Um, well, we did some compromise on this part. We could make it so perfect as to record all the native extensions at the compile time, but that is really hard. For the moment, when you call DL open or load library executable on Windows, we actually extracts that file to a temporary location. um, but it works. For now, it's a temporary solution. We extract it to a temporary file and then do the DR open on the temporary file, so it still works. And when the process exits, we'll delete that file. So native extensions work. So what about Rails? Why does Rails work? Um, this example, Rails is special. Um, it will create some files in your root of your project. But squash.fs is read-only. You cannot write anything to it. Like Rails will write a lot of logs into the root of your project. It will create a lot of temporary files. So how do we solve that? Um, Actually, we also intercepted some of those calls to a temporary location. So when it tries to write files to the squash.fs, we actually redirect that call to a temporary location and remember the file and also delete that temporary file when we exit. So if you want to see the files that got created, we have a special environment variable for it. Let me create a new folder so that you can see. And I move the Rails inside of it. And if I run it with IO work dir, and I say this dot is current dir, and some things will appear in there. Oh, I'm sorry, should be. You can put it there. So something already pops up. We can delete that first and run it again with a server. You will see that the log folder and the TMP folder are just created because they're trying to write it to the root of your project, but we redirected that call to a temporary location, and that temporary location was specified as the current directory. So the log is there. And your config is there. So if you're really going to distribute your Rails app in this way, this is an opportunity for you to speed up the config to make it configurable. So that it distributes with the config folder, but not your code anymore. That's how it works. So in summary, this is your project, and we use make squash.fs to compile that to yours.squash.fs. And we compile the two libraries, libsquash as the runtime access to that file, and libautoupdate to give you an auto-update feature. And we compile the Ruby runtime. And then as last step, we
PPAP.
So it's sort of like the PPAP process, right? So it's
I have a pen. I have an apple.
Your
Apple
project
pen.
libsquash.
I have a pen. I have pineapple. Pineapple
Ruby
pen.
runtime.
Apple
Your project
pen.
libsquash.
Pineapple
Ruby
pen.
runtime.
Pen
Your
pineapple.
project
Apple
libsquash
pen.
libautoupdate Ruby runtime.
Pen pineapple.
Your project
Apple
libsquash
pen.
libautoupdate. We statically link them together. It becomes your.exe, and you distribute and enjoy your executable. Thank you very much.